Welcome back to this video segment. In this session, we want to discuss a little bit of elaboration on the setup time itself and its effect on um, product variety and volume, right? So how you can compete based on that particular variety axis and volume axis. So I already touched on the nature of setup time. That is the way we look at setup time in lean operations and manufacturing in general is that reducing setup time is always the good thing. It's always a good intention. It's always a good goal. It's only whether we can afford it, whether the pain is not so large enough that we can absorb it, that we can withstand it, and there is a brighter future, right? So there is a greater production capacity to meet the high demand that we have studied or known from the market. So reducing setup time is always the right thing to say. I said that before, but I want to sort of emphasize this here again. It's the right thing to say and do, but the how part is very difficult. Why is it the right thing? Because it always helps to improve the effective capacity, CBS, the capacity in the presence of batch and setup. So when you reduce all the way down to zero, CBS just becomes CML, the machine label capacity, the actual original 100% capacity that you have invested in buying this machine, you get it back. All right, now we kind of realize that, oh, it's not just a simple thing as pay the money, pay the price, and get this super duper machine, and that's it. Let it run, and we get the capacity. Uh, Due to production, due to various either regulation, policy, design, and various reasons, we want to have batch, and we end up having setup time. And when you have setup time, the lesson learned here is pay attention, right? So don't let setup time increase arbitrarily. Now you might be wondering, we bought this machine that can process a tray, and then when it can process a tray means it can accept a batch of items, like a tray of doughs, and the machine is designed as such, and the machine has setup time to get ready to process the tray, right? So that setup time, how can we ever reduce? So in the previous example, I said, well, you got to be prepared to pay a higher price, right, to reduce it. Um, Here, we want to look at internal and external setups. That means we break up the setup. Why we wait, why we cause the machine to idle, right, is due to setup. But setup can be, at least roughly, broken up into two kinds of setup. Internal, that is kind of internal to the machine, while the machine is operating, while the machine is having its own setup, that part that we normally associate with, that cannot be reduced, right? Because it comes with the machine. It is integral to the machine, right? Or if the machine processes halfway and is overheating and it detects itself overheating, it stops. Mandatory rest in order for it to cool down, then it will restart again or something, right? Some high-end printers have that. Then those are internal setups that cannot be changed. External will be, of course, external to that machine, right? So, or it can be external to a team of man-machine unit, right? No matter what, you can understand it's external. It is not built in. It is built on top, right? It is imposed on top onto the machine typically. Like, for example, company mandatory checks. So company, because of earlier incidents or quality feedback, now has a new policy. Supervisors must eyeball check the tray for any cockroaches, insects, right? Before inserting the tray into the oven or the molding machine or whatever it is, right? So you have to spend that extra 3 minutes inspection. Can we do away with it? debatable, right? Yeah, maybe at higher risk of lower quality at the end, maybe at a higher risk of customer dissatisfaction, maybe at higher risk of accidents, higher risk of fire and whatnot, right? So again, it's debatable, and that category of extended setup time, we call it external to the machine or man-machine team. Or maybe because uh, of company policy, the man-machine team, right? The supervisor, the operator is required to do exercise, yeah, to ease up the blood circulation, to loosen up your muscles. And some Japanese factories indeed do that. Yeah, so if that is a policy, then it will have to be observed, and that is external. So you have to loosen up your muscles so that you are more alert and you have less risk of getting your fingers cut off by the machine, right? So those are external setups, activities that can be done while production of the previous batch, okay, the production of the previous batch continues to occur. The production for the current batch obviously hasn't happened because it is setup time. We are preparing, we are, loosening up our muscles, we are exercising, we are inspecting. So that's for the current batch, hasn't happened. Then why do they say while production continues? That's the previous batch. Okay, and we can imagine that while the molding machine is busy doing the dose of the previous tray, the inspector, the supervisor can, at the same time simultaneously start to inspect the next tray, right now. Yeah. Provided, of course, your process is set up in such a way that the next tray has already come along, because the next tray could have been, stuck in the upstream. Who knows? In the feeding machine, in the preparation, in whatnot, right? So in our process diagram, we didn't have a resource step before the molding machine, but in the actual situation, there could be. So if your process design is not designed in such a way that the previous tray is available for the inspector, the operator of molding machine, to simultaneously check while the molding machine is molding the previous tray's dose, then it cannot be done, even though we can overlap. So as you can see here, that if we didn't have overlapping, yeah, then it will have to be external setup, then internal machine setup, then production, right? End of the first tray, then eject, right? And then external setup time, inspection and whatnot, then internal setup, diagnostics, production, then external setup, internal setup, and production, right? So I'm showing a bit of variation in the internal setup also, and the external setup, but then the overall setup time is the same. And if we redesign the process, right? Remember, we were saying if you change the machine, very expensive, not only in buying the machine, but also in the setting in the machine, right? So you have to install, and that takes a lot of downtime, definite loss of revenue. Plus, yeah, the third factor, the high risk of losing your customers. They thought you closed shop, right? So they don't come back, or they know you're still open, but they end up discovering a better shop, or bakery shop, or source of food, and they don't come back, right? So there's a risk and a loss. But if you can overlap, right, uh, the external setup times, notice that I did not change the machine, so I don't run the 3 points, the 2 losses and the risks, right? So I just redesign my processes such that the production, this company policy, the external setup, is arranged in such a way that you're not inspecting the previous trade because it is still locked up in the machine, in the previous processing, right? So you cannot inspect. But then it is a company policy to loosen up your muscle. So I can do that to myself, right? While the previous tray is being process. So I loosen up my muscle, get ready, crack my knuckles and whatnot. Then the machine starts to prepare itself, self-diagnostics, and then the next tray of processing, the next batch of processing starts, right? And then in the meantime, I can then prepare. Maybe it is cleaning the place, so it's okay, independent of the previous output. But then if the company policy states something that is dependent on the previous output, then, well, too bad. Either you change the policy a little bit, or you cannot attain this overlapping, right? So if you manage to overlap, and you can only do that for the external setups, the internals are necessarily sequential, right? So recognizing that there is external setup time that can be kind of like done away, right? Hidden away while we are still producing. We are not skipping the external setup, but then we can overlap it, therefore saving time. And you notice that the overall production time end up being a lot shorter, right? The longer your external setup and your ability to overlap them, the longer is the savings, right? Yeah, and the shorter is your overall production time. So in a way, we are not shortening setup time. So it may be a little bit confusing to think that external setup times can be reduced or removed. Actually not. The setup time is never removed nor reduced at the risk of lower safety, higher chance of accidents. And no, we are not compromising, but we kind of cleverly examine the external setups and the nature and design our process in such a way that they overlap so that concurrent setup and production can happen. Also, if you can do that, if there's a big if, but at least it won't incur huge amount of costs, upfront costs, and very high risks, right, of customer losses and all that. Okay. So that's internal and external briefly. Then there is this notion about SMED, and that's a nice thing to quote. So what's good to say? Reduce setup time, right? Another thing is, for example, using SMED methodology, right? You can just think of it that way. Actually, it doesn't tell you how. SMED means single minute exchange of dies, and it's more like a legacy name, originated from this Toyota expert, Shingo Sensei, right? So he crafted this name because in the 70s, when Toyota was like, becoming bigger and bigger in car manufacturing, it has to increase the capacity. But you cannot always ask people to work faster. You cannot always buy faster machines because Toyota is already the kind of the leader, right? So who can give Toyota faster machines, right? So you have to have clever ways, and this SMED represents more like an idea. What's the idea? The idea is the aim, the goal, the intention to reduce the setup time to a single digit number of minutes. So presumably in those days at that time, the exchange of dyes, the coloring dye, changing of the painting for the cars, the dyes, require extensive setup time. Also, it's like you want to paint this car red, and then after that you want to paint the next car blue or silver or gray, right? All the layers of paints, because one car needs like many layers. I don't know how many layers, like 7 layers. Not one layer, right? At least 4 or 5 layers, if not 7. So the many layers of paints will have to be changed. So even one layer of paint, when you change the color, apparently, right, in those days, in that setup in Toyota, it was an extensive task. And so we already learned that when you have long, severe, right, extensive setup time, big hit, big penalty in the overall, first of all, the resource capacity. And if it's so severe, you will tend to pull down the overall process capacity because you are the lowest king, right? If you're the lowest in all the resources, then you basically define the process capacity. That means Toyota's ability to produce cars is as low as your painting shop goes. And so this SMED represents an idea. And in those days, Shingo Sensei says, well, let's overlap the external setups. Yeah, because remember, to reduce the hardcore setup, which is in our term, the internal setups, is not possible. So the idea is then to engineer the process design, look at the external setups, overlap them as much as possible, and then you result in having this reduction in overall production time. And then that means within the same real time, you can have more runs. You can paint more cars, right? And so the goal is last time, maybe 30 minutes, 2 digits. This time, after the SMED, you get it down to 8 minutes. Better still, 6 minutes, something like that. Well, of course, modern days, with a lot of robotics and, mechanical automation, this is, very easy. I mean, at least with the modern days competitors, it is doable, right? But then still, this thinking survives, as in, let's use the SMED, right? So currently we are having a 30-second setup time. Our production time is uh, 10 seconds, right? So 30 seconds is a heavy burden, right? So can we look at splitting the 30 seconds into internal and external? That's the SMED idea. Yeah. So that's the goal. And you can always use this as a quick answer to how do you do it in exam questions, right? So if you are posed as a consultant and say, how would you suggest John, the bakery shop owner, to improve the effective bread making capacity, right? So, John can look into reducing setup time. For example, he can implement SMED ideas, right, to try to reduce the setup time. But that's specifically how. Well, very difficult. You need a lot more information. So don't try to even elaborate. Okay. Going to next topic, setup time and product variety. Uh, that means the impact, the effect of long or short setup time on the company or business ability to generate or produce different models of goods. So when setup time is large, we learned already, right? The fixed cost is high, so your net production capacity is very low, high penalty. Yeah. So if it is production capacity is very low, right, your ability to switch into different what do you call that? Your ability to switch into different models and designs will be weakened because every time you switch, you will incur setup time. And that's part of the assumption here. We are saying that the setup time is incurred due to changing the models, right? Changing the color, changing the molding template, changing the ingredients, and so on. Yeah. So because you do that, you have huge setup time, and it cannot be dealt with, cannot be reduced, then your ability to have variety is really very low. So very hard to compete based on um, large quantities of variety and high variety. So it is better to go on volume rather than variety. So don't try to switch and say that you can make a lot of different choices for the customers. Right? Try to compete on volume, because if you have huge setup time, for example, right, the printer shop, the traditional printer shop, if you have talked to them before, I think now fewer and fewer. Most of them switch to more modern laser printing techniques, or digital printing, they call it. But the traditional ones, when you give them, when you want to print, for example, color flyers, so you give them a color JPEG image, they will have to go through a very expensive and time-consuming, relatively speaking, process of splitting the color image into 3 colors. I think it's the CMYK thing rather than the RGB, right? But whatever it is, it has to split into the 3 color format, or they call it the template or something. All right, so the 3 colors. And once they have done that and you cancel your order, they're going to like scream and yell at you, right? And it's usually there is a minimum order quantity because it wouldn't cover the fixed cost of producing these color templates. So that is when the setup time is very high. Or the setup time is very high, time consuming, and also each template is expensive to make. And the money axis is not represented here, but at least it's also time consuming. So setup time is high, and so the ability for that kind of traditional printer shop to offer to customers, no problem, give me, you can print 10 different designs, each one 100 copies only, no problem. Very hard for them to promise that. Very hard. They would want like minimally 10,000 pieces. Then you're like, what? I only need 1,000. But sorry, minimum 10,000. You just throw away the 9,000. Whatever it is, they don't let you go, right? So they need you to print minimally certain high quantity so as to justify the huge cost in setup. And so they will entertain customers more on volume. Okay, so you have one color flyer and you want to print two-sided, never mind, but you are printing 100,000 flyers. Okay, maybe for election campaigning, whatever, discount coupons and all that. Fine, good, nice. They like this kind of customers, right? But then, if you are also a printer shop and you are competing based on variety, and you purchase, as what I'm showing now, laser printer, okay, or digital printing, right? They call it the digital printer. So the digital printer has, of course, all the electronics and very fast switching mechanical movements inside, all engineered properly for robust, high, what do you call that, high usage scenario in business settings, meant for printer businesses, right? So then the setup time is low. It's low compared to the competitors who are in the traditional printing, three color splitting, that kind of business. So it's low. But of course, amongst the digital printer manufacturers, there are also longer setup time printers, shorter setup time printers, right? So we're talking about compared to the traditional. So low setup time, and therefore the CBS, the net capacity for that digital printing shop is high compared to the traditional printers. And so the variety is the ability for that digital printing shop to offer variety. What do you mean by variety here? Well, the digital printing shop can then say, oh, you are a student from NTU, right? And you want to print 10 different t-shirts, right? And each t-shirt is just 10 shirts for 10 teams, is it? Okay, no problem. Even one shirt is fine. That means one shirt has one separate, different picture. That is unimaginable kind of business for the traditional printing shop that has to split each picture into three colors in a very expensive, time-consuming way before they can start printing, right? So with that kind of technology, very short setup time, super short setup time, you can offer this kind of variety, convenience to your customers. Very, very small batches, so small that one print is one picture is doable for them in real life, right? It's real. And so you can then compete. If for this kind of business, you want to rather compete on variety rather than volume. So for the digital printing, last time at least, when you want to print 100,000 pieces, they will say, cannot, right? Because they will not be able to do that. Either the printer overheats, or they don't want you to swamp out other customers, because then they have to tell other customers, sorry, we cannot print today. Then they run a risk of propagating this idea that they are not receiving customers anymore, right? So they might not want you to choke them. So in a very strange way, you give them 100,000 pieces of printing they don't want, right? So, but then I think more recently, these smaller businesses, they also wise up, right? So they also can take it, and somehow they manage it. But I'm just saying that, like, in these two extremes, that's how you can see that setup time matters. So and also you notice that how do you get a very short setup time? In this digital printing business, they get short setup time due to the digital printer, right? So technology. So oftentimes reduction in setup time is due to technology. Next, we look at the top right end here. Of course, by now it shouldn't be stranger to you. The x-axis tends to be always the cost efficiency. Of course, it's printed as cost here, but you should understand it, right? Because it has to be the bigger the better, the more to the right, the better. So low per unit cost. So cost efficiency, yeah? More to the right is better, higher cost efficiency, so lower variable cost, lower per unit cost. Okay, so to reduce setup time, we go from here to here, right? So if you can reduce setup time, then you are at a higher frontier. But remember the frontier? The frontiers are like the ISO investment, right? Like having the it traces out the realm of equal amount of investments. Okay, now you can see, right? So it traces out the realm of equal investments. So all the companies that are here means they share the same amount of investments and they are at the same frontier, yeah, the same frontier. So reduce setup times, it's good. Um, currently we are now, right? Currently we are now. If setup occurs at bottleneck, that means well you should interpret this setup occurs as severe setup. Severe setup time occurs at bottleneck. The largest setup time is found at the bottleneck itself. Maybe because of that, that's why this resource is a bottleneck. So setup time, severe setup time occurs at bottleneck. Then the fix, the way we fix this is to use larger batch size. Of course, assuming that we are unable to, reluctant to, to reduce setup time. So whether external or internal, and we examine everything, we cannot re-engineer the process, not even setup time, external setup time can be reduced, so no choice. So then use larger batches. And if setup time occurs, severe setup time, larger setup time occurs at non-bottleneck. For example, in our original bakery with 3 stages, right? 2 per minute, 1 per minute, 6 per minute for the packaging. So 6 per minute for packaging is very, very high capacity. And severe setup time occurs at the very, very fast machine, non-bottleneck packaging machine. So it will reduce the CPS from original CML 6 per minute all the way down to maybe 3 per minute, right? It's like a 50% penalty, right? Good. Because it doesn't become a new bottleneck. Our bottleneck is still the baking machine, right? So then the fix here is to use smaller batches. Smaller batches. How come? Well, because you are unable to make the bottleneck work faster anyway, right? Yeah, and the severe setup time occurs at the non-bottleneck machine, and it has reduced to the CBS to still above the choking bottleneck resource. So now the yardstick, the metric to measure performance is more like the flow time. Remember that bigger the batches, all the things inside all the flow units inside the batches cannot be released until the whole batch is done. So if you have smaller batch size, then the flow time will be reduced, and that is good, right? So we will then do that. When the flow time is reduced, flow rate is assumed to be constant. Then using Little's law, WIP is reduced. Therefore, the overall total amount of opportunity costs that are tied on the WIP on the conveyor belt is reduced, right? So overall, a good thing for the business. Lastly, two terms that we use to talk about bottleneck in particular. So when there is blocking, right? So what is blocking? Occurs when the activities in the stage must stop because there's no place to deposit. The item just completed. Okay, so when there's blocking, usually at the bottleneck, right? But then when you have a lot of things that are processed and it cannot be output, right? There's no place to deposit the item, the finished good. So it's like choking at the output. Choking at the output is blocking the continuing production, right, of this resource, then basically you you're said to be generating a blocking situation, right? So there's no room for the employee to place a unit downstream. So in a messy factory, as you can imagine, the worker will, I don't know, put something into a box, right, packaging, right, manually, then put it aside. But then if there's no one to clear, or the space to let him put is too small relative to the rate at which he completes the packaging, then you'll be starting to pile up, right? At some point it will fall down. At some point it becomes a mess. At some point he simply says, I cannot do this, right? Because the finished goods are starting to block his hands movements, right? So then it is choking that stage, and then all of a sudden that non-bottleneck resource becomes a bottleneck. Right on, yeah. So, and of course, current bottleneck resource also tends to be blocked very easily. So that's something to watch out for, right? So block it. Okay. Starving is the other way around at the FR in. So if blocking is FR out is being choked to force into zero, right? Then starving is forcing FR in to be zero. So if you not choke, but cut off the supply, the input into the resource, then the resource has nothing to work on, no raw materials to work on. Then, of course, there will be nothing coming out, and of course, everything downstream will be starved right now. Yeah. So basically, the process also has to stop. So the two situations, blocking and starving, will choke the process, will stop the process. So starving occurs when activities must stop because there's no work. Okay, employee is waiting for the upstream to finish processing. Would you like to be starved of lean operations exercises? Yes, right. So maybe this is an exceptional example where it is good to starve the resource, the students, right? But now you understand, huh? So starving, no good for the process. Blocking, no good for the process. That's all. Huh? Okay, that's all I have to say about this slide here. All right, so see you in the next video. Bye.